For the following example, we need to find the mean of the heights for team 1 and team 2. The mean is equal to the sum of all the scores divided by the number of scores. 72 plus 73 plus 76 plus 76 plus 78 divided by the number of players, and we have 5 of them. The answer is 375 divided by 5, which is 75. For team number 2, we will do the same thing. We'll add all the scores, or all the observations, all the heights, and then we will divide them by the number of players. 67, 72, 76, 84 divided by 5. Now we're going to get 75 also. As you can see, the mean is not that reliable to describe the variations in the data. We're going to use other statistics to do so. The most basic one will be the range. It's the difference between the maximum and the minimum. So the range for team 1 will be the biggest value, the highest value, 78, minus the lowest value, 72. So the range is going to be 6. For team 2, the range will be the highest value, which is 84, minus the lowest value, which is 67. So for team 2, the range is 17. In order to determine the range of these ages, we're going to list them in increasing order. List the observation in increasing order. 9, 21, 45 comes next, 51, and 54. We automatically get the lowest number and the highest number. So the max is 54 and the mean is 9. So the range will be the maximum number, the highest number, 54, minus the lowest number, minus 9. So 54 minus 9 is 45. 6 students took a test. You want to have the range, find the range of their scores. List them in increasing order: 43, 56, 69, 70, 75, and then 82, 87. So the max is 87. And the mean, well, the mean is 43. So the range is going to be equal to 87 minus 43, which would be 44. Good for students to remember. The range is the most basic of the measure of spread. It's just the highest minus the smallest. When the mean is used as a measure of the center, the standard deviation is the preferred measure of variation. It measures on the average how far the observations are from the mean, giving a better description of the data. To find the standard deviation of a data, the first step is to calculate all the deviations from the mean. The mean as calculated previously was 75. Now, we need to subtract the mean from each observation. The one to the left will give us negative answers, and the one to the right positive answers. 73 minus 75 is negative 2. 76 minus 75 is positive 1. We're going to get positive 1 again, and 78 minus 75 is equal to positive 3. Well, what is the value of their sum? The value of their sum should be 0. So negative 3 plus negative 2 plus 1 plus 1 plus 3 is equal to 0. We didn't go that far, but we have the deviation. If we square them, then we'll eliminate the previous problem. If we square them, then we can add them and average them. Negative 3 squared is 9. Negative 2 squared is 4. 1 squared is 1. Once those values are squared, we will not have 0 as our total, but we will have a sum that can be averaged. Now, the total is 9 plus 4, 13, 15. Okay. So the total is 24. We said that the total of the squared deviation is equal to 24. Now, we need the average of that total, and it's going to be the total divided by n minus 1 because of the degree of freedom. So the average is called sample variance. The sample variance will be 24 divided by 5 minus 1. So the sample variance will be 24 divided by 4, which is 6. Now the standard deviation will be the square root of the sample variance. In other words, we will take the square root of whatever we squared before so that we get a better average. The standard deviation indicates how far on the average the observations are from the mean.